Requesting connection. Established. Encrypted. We're live. The show you've been asking for. Advice, technology, and community. Linux first, all others second. This is Ask Noah.
Live from Ultispeed Technologies, the Ask Noah show starts right now. This is the show where we came to do all the things on Linux they said couldn't be done and take your questions on how to do the same. The phone lines are open this hour. To be a part of the program, it is a free call, 1-855-450-NOAH. That's 1-855-450-6624, or send an email to live@asknoahshow.com. My name is Noah Chalai. I'm your host. Delighted to be here with you as another episode of the Ask Noah show kicks off this hour. I can't get enough of dark mode. In fact, I've said numerous times before, I think that things that are presented in a dark appearance tend to look more professional, more robust. And the other thing is, aside from it being kind of a first world problem, there are some actual major advantages to setting your system up to present things in a dark way. Improved readability of text, better contrast. You actually reduce the strain on your eye. You can reduce the eye fatigue. Less flicker. You also expose your eyes to less blue light, and you're less prone to triggering photophobia. And you can also save small amounts of electricity. And so for all of those reasons, plus the fact that it just looks cool, I suggest that you always investigate dark modes. Well, one of the things that I've run across as kind of a problem, when I go to certain sites, sometimes the site doesn't support dark mode. And I've tried a number of different dark mode extensions for both Firefox and Chrome, and I've kind of settled on Darkreader. You can learn more at darkreader.org. A couple things I like about Darkreader. Their privacy policy says that they don't collect any information, and I very much like that. It also is very well reviewed in the Firefox store, or in the Firefox extension store. Every site that I have gone to looks fantastic when it's re-rendered with the Darkreader extension enabled. They give you two options. The first option is you can actually turn the extension entirely off or on. And of course, you would want that. But the other option that they give you, which I think is really brilliant, every site that you go to, you can go up into the Darkreader extension, you can tap on it, and there's a little check mark. And if you tap on that little check mark, it turns into a little X. And that excludes that particular site from being rendered in dark mode. You also have the opportunity to go the other direction. Maybe you're a person that prefers everything light. I'm not sure why, but if you wanted to do that, you can install the Darkreader extension and you can click on the light side and it will translate everything into a very light theme. And having used that for the past 2 or 3 weeks, it is quickly becoming one of the first things I install after Bitwarden to keep things looking good on the web. You can learn more at darkreader.org, and of course, we'll have a link for you in the show notes over at podcast.asknoahshow.com. In the ever-evolving world of cat and mouse, the battle between cheaters and game developers, Riot Game is taking expanded measures to protect legitimate players in its now tactical combat game, Valorant. But Riot's new Vanguard anti-cheat system involves a kernel-level driver that has very low-level access to your system and is raising some eyebrows among both players and security experts. So here's how this works. Essentially, it makes use of a kernel mode driver that starts operating as soon as the Windows system boots up. Now, the previous way that a lot of these anti-cheat systems worked was they ran at a user mode level, just like any other Windows executable would. Cheaters have started to use code signing holes in the Windows corruption that exploits the Windows system to create cheating software that can run at the kernel level. And of course, with that more privilege comes with more access to the system. And those kernel level cheating tools, they claim, could themselves look completely legitimate to user level anti-cheat tools, which have more limited visibility into the inner workings of the OS. I might add that's what we want. At the kernel level, any flaws in Riot's driver could create system-wide blue screen of death-style crashes as opposed to the more localized application-specific glitches. Now, there are some serious oversights that occur when these types of systems are put in. And in this particular case, if there is a serious oversight, like a buffer overflow exploit, that would allow an attacker to install their own malicious code at an extremely low level where it would be very dangerous and difficult to detect. And if you think I'm just coming up with that off the top of my sleeve, I invite you to take a look back at 2005 when Sony was sued over their DRM rootkit. Sony's now infamous decision to use the system destabilizing DRM malware in order to fight piracy under a subject line containing the words photo approval. Malicious actors sent a mass-mailed email called STIX-E, the STIX-E Trojan virus, to British email addresses and the British antivirus firm Sophos. When recipients clicked on the attachment, it would install malware that tore down the firewall and gave hackers access to a PC. That malware then was hiding in the Sony software that was also hidden. And so the software would have been installed on the computer when the consumer played the Sony's copyright protected CDs. So the TLDR there is, this is, of course, if you give an anti-cheat program more access to the system at a very low level, it's going to be able to be more effective and catch more potential cheat vulnerabilities. My question to you would be, at what cost? At what point do you say to yourself, I'm not going to let a game developer, I'm not going to let a game system decide how much access they're going to get to my system. I'm just not going to allow that. And so when I want to play your game, if you want to fire it up in user space where everything else is, that's fine. When you want to start putting stuff into my kernel and digging deeper than even I go on a day-to-day basis, I have a problem with that. Again, 855-450-NOAH. That's 1-855-450-6624. The email, live@asknoahshow.com. That is how you join the program. Kurt calls from Ohio. Hey, Kurt, welcome to the Ask Noah Show.
Hey, Noah, how's it going?
Good. How are you?
Not too bad, not too bad. Got a question about my church here with the, obviously with the COVID-19 stuff going on, they've had to really quickly go to online streaming masses on the weekends. And they kind of it's a small parish, so they kind of got caught off guard with that a little bit. And just kind of curious what you'd recommend equipment-wise. I mean, it's kind of a lower budget type thing, cameras, that sort of thing for a kind of a smaller parish type thing.
Sure. So to start out, the most important thing, or the thing that I would focus on, would not be the equipment, it would be the streaming service that you use. Are there ways to set up Nginx that can rebroadcast RTM? Well, let me start with this. Let me back up a little bit further. You could, in theory, set OBS up to just generate an RTMP feed, and then you could mail that link out, or you could open holes in your firewall, whatever it would be, and send the link out to various people, and they could all pull that RTMP feed, right? The problem is, after about the fourth or fifth person that tries to pull that 720p stream off of your church's internet that probably tops out at like 10 megs up or 15 megs up, all of a sudden the stream's going to start crashing because the church upload bandwidth can't handle anymore. And of course, then other things in the church are going to start to break as well. So you want to use something in an intermediary step, also known as a CDN, or a content distribution network. And the CDN that I would recommend you check out is Scale Engine. They have a free 30-day trial that you can sign up. After that, it's only $29 a month. They'll allow you up to 5 streams. That is to say, you can generate 5 different sources of content, and then anybody can pull those streams down. They also include an intuitive dashboard that you can use to turn the streams on and off. They offer the ability to record, and my favorite feature, which is included for free by Scale Engine, and it costs extra pretty much everywhere else, they have the ability to push to Facebook, Twitch, YouTube, so on and so forth. And so when you sign up for that $29 service, you have the ability to push everywhere your participants are going to be without costing any extra money, and Scale Engine will handle all of the all of the technical resources required to do so. So all you have to do is, you said, what's the cheapest way to do that, essentially? Purchase a used Dell Optiplex for $150, $200 on eBay. Try and go, I would say, I don't know, try and get 3 within the last 3 years, maybe old, and spec that out with at least 4 gigs of RAM, preferably 8. Get an SSD in there. The nice thing about OBS is it just sips CPU, so you can run that. You can run it forever. It'll just run. And the next thing that you're going to run into is a USB bandwidth limitation, because when you start plugging in 1080p cameras, when you start plugging in audio interfaces, you start to eat up USB bandwidth in the computer very quickly. And so the way that you get around that is you use a PCI card that's attached to the PCI bus that contains individual USB host controllers for each individual USB port. And what that allows you to do is plug the audio interface into one and your video capture camera into the other. And both of them will function simultaneously because they're both on their own individual USB bus. Now, I'll have a link for you in the show notes where you can purchase such a card. They're about $99. And from there, what I would recommend, if you're trying to keep it absolutely bare bones minimal, I would tell you to look at like a C920 or a C930. This is a USB powered webcam that will deliver 30 frames per second at either 1080p or 720p. If you want to go one step higher than that, then I would purchase something like a Magwell HDMI capture card, which uses the V4L system in Linux. So you're just going to be able to plug it in. It's going to look like a webcam, like any other webcam would from your Linux system, but the difference is this webcam is going to take a feed directly from HDMI. And so that enables you to purchase like a Sony Handycam that has optical zoom and a slightly better picture than a webcam is going to have. It also allows you to mount it on a tripod and put it somewhere in the church that, allows you to frame your shot a little bit better than you'd probably be able to do with a webcam.
Gotcha. Okay. Have you had much experience with, we had the thought of maybe doing like an IP cam as well. That way we could pull it over the network rather than, since there's not necessarily a good spot to put a camera per se and a machine there.
So there's two ways you can go about doing that. The first way that you can do that is you could use something like Axis, which are very high-end. They're really made for security, but they are very high-end IP cameras that will generate an RTSP video feed that you can then pull into OBS. And so that's certainly one way you can do it. Now, the downside to using a solution like that is the feed is going to be variable. It's going to be, the picture is going to arrive in like 4.5 seconds, then 4.6 seconds, then 4.3 seconds. We can deal with an offset, right? We can deal with an offset. That's not a problem. We can go in there and change the audio delay so that the two match up. The problem is when it's not a consistent offset when it drifts. That makes it very difficult to match the lips up with the voice. Now, maybe you don't care about that, and maybe the cost benefit of that will offset the perceived downside, but the quote-unquote correct way to do what you're talking about doing would be something called NDI, which is essentially encoding low latency, high quality video over a network stream. And of course, if you went to any large sporting game, this is how they're doing it, right? They have cameras, they're encoding that video over NDI, they're putting it on the network, and then each individual station that wants to pull a feed is pulling those particular RTSP streams off of the network, or NDI streams off of the network. And OBS does have support for NDI, and so you certainly can compile it with an NDI driver and do it that way. What you will find is it is infinitely more expensive than just capturing HDMI.
Gotcha. Okay, that sounds good. And one last quick question on they also need a bit of a Wi-Fi revamp there. Would you still go with the Ubiquiti AC Pros? Would that be top of the list?
Yep, I would, because you're gonna purchase one. You're gonna be able to spin up a controller on any Ubuntu system, or you can purchase their Cloud Key for $79.99 and just plug it in and have a built-in ARM controller that just attaches to the network, and it's just gonna make your life for managing it a lot easier.
Okay, that's kind of what I was thinking. So I will take a look at the Magewell and the camcorder option. I think that'll probably be the best fit for what we're looking to do.
Awesome. Thanks for the call. 1-855-450-NOAH. That's 855-450-6624. The email, live@asknoahshow.com. My next guest, Jason Donenfeld. I am so excited to get this guy on the air. You guys have no idea. I have been praising Wireguard since the day it came out, and I have been using it both in production and in my home lab to test things out. It is the next evolution of VPN. It is a VPN created from the ground up with the expressed purpose of being easy to use, simple to set up, secure, and use a modern code base. So without further ado, Jason Donenfeld, welcome to the program, sir. For those that aren't familiar, let's start with this. What is Wireguard?
Wireguard is a secure network tunnel originally made for the Linux kernel. So what that means is you could have two computers separated through the internet or through any network, and you have a secure tunnel from one to the other, like your own private internet. So people can use this between data centers, for example. Two data centers that are far apart, but they want to feel like they're connected physically. You use a secure tunnel for this, but you can also use it as a VPN for your internet traffic. So If you don't want to use your internet at home, but you want to use someone else's internet, like a VPN provider's, then you can send your traffic through their internet. If you want to access your office's network or use your office's internet, you could use a secure tunnel for that as well. So in the past, these tunnels, these VPN protocols have been pretty messy. Things like OpenVPN and IPsec are extremely complicated, old, lots of legacy stuff. And so Wireguard is kind of a new, fresh take on the secure tunnel idea. It uses modern cryptography, best-in-class performance, and lots of kind of defense-in-depth security techniques to really reduce the attack surface in a way that the predecessors certainly don't have.
So we have, a lot of people have praised Wireguard for its simplicity and robustness, to include Linus Torvalds. Said he was very, very excited at the advent of having this VPN alternative. Now, I understand that this is a little different than the other flavors of VPN because this is actually in the kernel. What does that mean exactly?
So the kernel is the lowest level of the operating system. When people talk about Linux, maybe what you think of is something like Ubuntu or GNOME or KDE or something. But actually, Linux usually just refers to the kernel, which is this very low-level component that interacts with the hardware and gives other pieces of software a uniform interface for talking with the hardware. So the kernel provides things like file systems or the ability to display things on the screen or communicate with your keyboard. But it also provides a networking stack. So it talks to your Wi-Fi and Ethernet cards, gives things like TCP, but it also has network tunnels in it. And so the latest addition, as you mentioned, is Wireguard. So it's a little different to have this in the kernel. Previous VPN protocols like OpenVPN live in user space, which is kind of a higher level component. And the problem with this is that every time you want to send a packet through the tunnel, it means that user space sends the packet to the kernel. Kernel sends the packet back up to user space. User space running OpenVPN then makes some transformation to it, encrypts it, whatever, sends it back to the kernel, and then it gets sent off. So you have these round trips that really slow things down. So Wireguard will just send things directly to the kernel. Kernel deals with it, sends it off, and there's none of this back and forth trip. This also has advantages in the opposite direction. When you receive a packet with old OpenVPN way, the kernel would send the packet, copy it from the Ethernet card, send it back up to user space. User space does some transformation, sends it back down to the kernel. Kernel then sends it back up to the user space. You have this back and forth, but with Wireguard, because it's in the kernel, we can actually take packets directly out of the ring buffer of your Ethernet hardware. We have access to all the different memory addresses that the kernel does. So we don't need any back and forth. We don't need any copies of the packet.
I understand that the code base for Wireguard is much smaller than the code base of other competing VPN protocols. Is that advantageous? And if so, why?
Yeah, so we're around 4,000-ish lines of code, which is really quite small. And there are a couple advantages. And in the first case, there might be kind of a naive performance benefit of that. If you have less code, there's less for the computer to do, and so things move faster. Now, this is obviously not true. You can have really bad algorithms in a short amount of code. But I think when you're comparing something like Wireguard with around 4,000-ish lines of code to OpenVPN and IPsec that have hundreds of thousands of lines, it's just simply doing less, no matter how you slice and dice it. The real benefit that I see is security, where Wireguard is at the size that anyone can sit down for an afternoon and read through the entire code base. And I mean, I really mean read the whole thing, read every single line, because it's just not that many lines of code. I've worked in the security industry for many years, and a lot of times we get these source code review assessments where we're given this massive code base, 100,000 lines of code, and here's a time slice to try and read it in and find vulnerabilities, and okay, we do our job well and we find a bunch of vulns, and that's great, but there's always this question, what if we had more time? Some of these code bases are so big, is it really possible to cover the entire thing in some time box? And won't attackers always, theoretically anyway, have more time? So with Wireguard, hopefully there's not such an issue there where it's actually not that many lines of code. So given a pretty reasonable amount of time, you can in fact read the whole thing. And hopefully the small size will just make it appealing as something interesting and fun for security researchers to read as a weekend project. So I think in that way we get a lot more eyeballs. It also reduces the complexity quite a bit. Instead of tons of complicated interlocking subsystems like something like IPsec, we just have one very simple tunnel driver. So with reduced complexity, there's a lot reduced potential for bugs, smaller attack surface. So just in general, a better security posture.
Who is Wireguard ideally suited for? Obviously, people use VPNs for remote workers that are road warriors. We use, as you mentioned, VPNs inside of the data center to get traffic securely from one place to another. When you designed Wireguard, did you have all of these models in mind, or was there a particular user or use case that you had designed for?
I mean, initially I made Wireguard to kind of scratch my own itch. I wanted the thing for my own usage. And the other things didn't really serve that, so I made this thing that's small. But I think Wireguard usually fits into the traditional things that people want to use VPNs for. So sure, road warriors, people who work in offices, data centers, interconnecting, people who just want some other services, internet traffic, mesh networks. It's very interesting for. Wireguard intends to be kind of a low-level building block tool. So system integrators can build it into something bigger with integrations in places. So it really has this potential as a building block for all sorts of systems. And I think already we're seeing this being used for things I never envisioned. People are connecting it to distributed hash tables and just all sorts of creative things, because it is just a simple, secure tunnel. You can do point to point, you can do point to many, many to many. I mean, all these different topologies are possible. You just hook up the keys and then traffic can be sent, and there's not really much to do or configure as far as the tunnel part goes. So then people wind up using it for all sorts of things. So I think in general, it appeals for all sorts of different use cases. As far as users go, so we do have clients for all platforms, Mac, Windows, Linux, of course, Android, iOS. All different types of users can use it. But what we're seeing now is that people are building things on top of Wireguard to extend it to an even bigger audience. I think the appeal of it will wind up being pretty broad.
You mentioned that people were using Wireguard for a distributed hash table. Can you elaborate on what that is and what Wireguard is doing to support it?
Oh, sure. So people want to make mesh networks, and there are many ways for peers on a mesh network to discover each other. There are some, very interesting protocols like Babel or Batman that do this. But another idea that's been around for some time that people are connecting with Wireguard is you put all the different public keys in a distributed hash table. Maybe these are well known because of BitTorrent uses these for discovering different peers to download files from, but you can actually put anything in a distributed hash table and then discover all the peers that way. Add each of these peers to your Wireguard interface, and then you can talk to them. I guess people are interested in different geographic metrics within the hash table. How close are these peers? And so there have been a couple different attempts to do this. And it seems like an interesting idea. I just mentioned that because it's a kind of a very creative use of two different things that I didn't expect to ever be connected. But indeed, people are doing it because the simple Wireguard interface makes that possible.
To a certain degree, that kind of follows along with the Linux philosophy, right? You didn't make this massive thing. You just hyper-focused and made a very high-quality component here that people can then use however they see fit.
That's right. The Linux networking stack is kind of awesome in how modular and how many features it has. And a lot of people discovering Wireguard really love it. They, find networking exciting, and they get into setting up these tunnels. It becomes a hobby. People really get attracted to what Wireguard has to offer, but it seems like actually what's happening is they're discovering the magic of the Linux networking stack, which indeed has all these very modular components that you can fit together in interesting ways.
It sounds like Wireguard is a solution that if somebody hasn't used before, hasn't tried, they should definitely get started or at least give it a whirl. How easy or difficult is it to set up Wireguard, Jason?
It's significantly easier than the other the other solutions. There's no X509 certificates to set up. No certificate authorities. There's none of this. Basically, each side generates a public key. They exchange public keys. They choose what IP addresses they're going to use. That's it, and then they can send packets. Wireguard doesn't even have a concept of being connected or disconnected. Either the tunnel is there or it's not. It's up or it's down, just like any other network interface. There's no thing that the user sees that says negotiating, connecting, waiting for a response. There's none of this. It's just when you want to send a packet, you just send it. Wireguard handles all the negotiation and crypto stuff in the background, and it just works. So you swap public keys, you decide what IP addresses you want to use, and you're done. So it's pretty easy. We've intentionally held off on adding a lot of knobs and configuration options to it. Wireguard has kind of a one set of defaults, and that's what you use, and it works well. And the different parameters for making it work are basically automatically selected by Wireguard itself.
You mentioned earlier that a client exists for all of the major operating systems. Is that client a CLI-based client, a GUI-based client? Are there any plans to introduce a GUI-based client if there isn't one currently?
We have both pretty much everywhere that people are using UIs regularly. So here's the layout. On Linux, it's this kernel module. And we have the WG and WG Quick tools, which are CLI tools, and that's kind of the base. Then Linux user space has all this different plumbing. So now there are UIs that have been created by the network manager people, and there are kind of a couple other things that glue on top of the upper layers. Now, luckily, the Linux ecosystem is open source, so we kind of have all these different projects adding their take on how networking and UI should work together. And so they're providing the UIs there. We have on macOS both a command line client, written in Go, Wireguard Go, as well as a normal, good-looking Swift UI client that you can get in the Mac App Store. It's free, of course, open source, all that. And that just looks like a normal app, and you don't have to press any buttons on the CLI. On Windows, we have an MSI package that you install just like any other that provides you with a nice UI and administrative tools. But you also get the CLI utilities with that too. So that's a very interesting client in that it's made both for end users to be able to click around and do things, but it's also a super modular service-based design so that enterprise admins can integrate it into their deployments. So on that platform, we have both. Then on iOS, we have just the UI client because there's not really a super thriving CLI ecosystem there. Jailbreaks aren't super common these days. On Android, we have both. We have both the normal UI that's in the Play Store, but we also have these command line utilities that can talk to the kernel implementation of Wireguard if your phone has that in the kernel. And we've actually been talking with the Android team at Google about adding that by default to all Android phones instead of just special ROMs that people make. So on Android, we have both as well. Then on the BSDs, we have just the CLI. And I assume that, depending on how their UI ecosystem goes, maybe there'll be some things there, maybe not. I don't know.
I know when Wireguard first came out, for the longest time, the recommendation was, this is very exciting, it's very cool, it is a much-needed overhaul in the VPN world, but we don't recommend that it's used in production. With the inclusion of Wireguard into the kernel, are we now ready to say that this is ready for production use?
Yep. We're at 1.0, we're ready to go. I realize it took a while. Got emails every week, people very impatient. A lot of people even upset about this. Like, how could you put this out and then tell me not to use this? Don't you know how difficult it makes it for me to talk to my manager about it? All these kind of angry emails. But we really wanted to take our time and make sure we were doing this well. Get Linux kernel integration really streamlined, make sure that the security aspects were rock solid. There have now been a number of academic security proofs done on the protocol, so we're pretty certain about that. We took our time to get the crypto implementations as rock solid as possible. We have a lot of formally verified code in there, which is great. So, this is a security-oriented project, so we didn't want to rush it. We didn't want to jump the gun. But yeah, after a number of years of development, we've hit 1.0, and I think people can start running this in production. And hopefully we'll see a number of enterprise Linux distributions adding this shortly as well.
Yes. Yeah, I was one of I did not send any angry emails, but I may have had some encouraging emails to say, I love this product. I hope it is released soon because we're just very excited to have this. It's very cool. And, setting it up, it literally is, I would describe it as simple as if you have set up SSH before and you've generated an SSH key pair, you can set up Wireguard.
That's right. Yeah, it's same level of simplicity.
Let me ask you this, Jason. Is there any situation where you would say Wireguard is not suited for? Is there any environment or any situation where you would say this would be the kind of thing that you might want to look at an alternative for? It's not really what we designed Wireguard for.
Yeah, I mean, Wireguard is an opinionated design. So for starters, it's layer 3. It's for IP networks. Some people with older networks, weirder networks, don't want to be tunneling IP. They want to be tunneling raw Ethernet frames over layer 2. I don't think this is a great way to design your networks, a great way to tunnel things. But some people, for whatever reason, legacy designs or just weird preference, actually want layer 2. And WireGuard very explicitly does not do that. Let's see, there are other things where people are very interested in certificate authorities and X509 integration and kind of these big behemoths of kind of the PKI from yesteryear. And WireGuard does not use that. There's just very basic public keys that you can exchange. Now, of course, WireGuard can integrate into anything because it is this building block. You can build integrations on top of LDAP, on top of even TLS over some HTTP REST interface. There's kind of all this variety for how you could integrate it into existing X509 things, but it does not itself use X509. And there are a lot of kind of old school admins who still think that putting X509 in everything is a good idea. I do not think that's a good idea. So WireGuard doesn't do that. It doesn't encourage you to center things around that. But of course, you can integrate it into anything.
I have heard some of those discussions occurring. I have watched some of those discussions unfold at various different Linux conferences. And so to me, what I take away from this conversation, frankly, Jason, is that you really understand your user base. You understand the environment that you're working in. You understand the competitors that are out there, and you're trying to navigate those waters. And I think you're doing a great job. If you were to tie into LDAP, Active Directory, so on and so forth, because this is a module inside of the kernel, and there's a limit to how much stuff we want the kernel to be working on, would you say that the tie-in to some sort of central auth or LDAP, would that happen in user space then?
Yeah, that's right. I mean, the kernel part of WireGuard is just this very basic tunnel. You exchange keys, you exchange IP addresses, and then you can start sending packets. The question is now, what keys do we exchange? How do we get these public keys? How do we agree that these belong to each other? Some people exchange these in person. Some people exchange these over SSH. There are kind of all sorts of ways to exchange it. So if you wanted to instead say exchange it over LDAP or exchange it over an HTTP REST interface, that would just be another way of exchanging it, something exterior to WireGuard. So WireGuard doesn't really care how you learn this initial information about each other, which I think is why it's so appealing to systems integrators, because they kind of already have these things set. For example, people doing cloud deployments are now running this with Kubernetes, where it turns out that Kubernetes already has all these deployment things, so you can send things to all of your different machines. And adding WireGuard information in that is just another easy thing to slap on top of the already existing deployment mechanism. And then you give it to WireGuard and the kernel does this thing there. So if you wanted to do this with LDAP or Active Directory or anything like that, it's the same exact thing. You use the things you already know. Once you get these keys, you tell WireGuard about it, and then WireGuard takes care of the rest.
I understand that getting WireGuard on Windows had some challenges and created kind of an experience for you. Talk about that.
Yeah, Windows was definitely a challenge. And, Windows programming always is. A lot of Linux people or open source people will speak very poorly about programming on the Windows environment, how much it's awful, they hate it. But to be honest, once I get going on there, I get kind of addicted to it. It's so complicated. There are so many different APIs and competing design decisions that went into it. It's like an archaeology of computing. You can just see decades of different teams at Microsoft competing with each other and layering this stuff on top. And The end result, yeah, can be kind of filthy when you start to have to program this, but it's also a thoroughly addictive, stimulating puzzle to solve. So the situation when we began Wireguard was that Windows does not really provide a normal ton interface like the other operating systems do. On macOS, you have uton. The BSDs, you have just a normal ton tap. On Linux, you have devnet ton. But Windows, that's not really the case. And so for the most part, people who want to do interface level networking there in user space have been using OpenVPN's TAP6 driver. So that's usually where people start. So I took a look at that. And like the rest of the OpenVPN project, it's like terrible, crumbling old code. There's like a DHCP parser in there, which you don't want in the kernel. It's really just a mess, and performance is bad. So it seemed clear from the get-go, all right, we can't use that if we're really serious about giving a piece of security software to users. It doesn't seem like there's much else around, so I guess we need to develop a kernel driver. So we made this thing called Winton. You can read about it at winton.net, which is just a generic layer 3 ton device for Windows. Works pretty much the same way as DevNet ton in Linux. There's some nice innovations in there where we use shared ring buffer between user space and kernel space so that there are fewer syscalls, because syscalls on Windows are somewhat slower than on Linux. And this winds up being a very short amount of code, but highly optimized, super fast. And now actually OpenVPN has ported their stuff over to using Winton. So there's kind of some nice cross-pollination within the open source ecosystem there. So we developed Winton. We got it signed by Microsoft and all set. So that was the first step. So now we have a ton interface we can use. So then the next thing was porting our WireGuard Go code over to Windows, making it work with the Windows service management architecture, adding a secure UI to it, making sure that configs are in a secure place of the Windows file system, that encrypted using the protection APIs Microsoft has. There's just kind of all sorts of weird APIs we had to interface with. There's also quite a lot of reverse engineering involved. The networking side of Windows is not super documented, and when I talked to Microsoft about it, they wanted me to sign an NDA to get info about this, which of course I'm not going to do because it's open source software. So there is tons and tons of reverse engineering of kernel, of the NDIS driver, of various user space components in Windows so that I could find the right APIs to use. One interesting example is when you create a new network interface, Windows likes to give it a certain GUID so that it can identify that network. But with something that's a virtual interface in layer 3, WireGuard or Winton interfaces, it would give a different random one every time, and you would wind up with all these different networks that just clutter your system. A way to make that deterministic or to set it beforehand is completely undocumented, but it turns out there is a way. Microsoft uses it. And so we just had to kind of sleuth around to find that, and that was quite the effort. So there are just kind of tons of tricks throughout. And on Windows, a lot of emphasis was, all right, make this work for users, but also be sure that IT admins doing enterprise stuff can integrate it in all sorts of different ways. You can control from the command line. You can add and remove services using usual things. You can install it using the group policy installation. So we really tried to make it feel like a normal Microsoft system level component, despite it being third party.
You know, what I like about this, Jason, is what I'm hearing is Windows was not a second class citizen. It had your full attention. And yeah, you started this project to be integrated into the Linux kernel, but the reality is no matter what a person's choice of platform is, they're going to be delivered a Class A experience when using WireGuard. And I think that speaks well of you and your team. Let's take a look at the other side of the equation. What was the process like getting WireGuard into the kernel? What was what parts were good, what parts were bad, and what parts could maybe be improved?
Oof, it was a struggle. So in the beginning, I was most worried that the IPsec people would not want it in there because it kind of competes with it. They might say, well, WireGuard already, or the Linux kernel already has this VPN thing. Well, why do we need WireGuard? What's the point? But actually, I went to some Linux conferences and talked to the IPsec guys, and the IPsec maintainer is actually a great guy and wonderful to work with, and he's thought through the same things I've had to think through with WireGuard, and that aspect was not a problem at all. And there's actually some really great reception from the networking community there. Did not expect that, but kind of right off the bat, they were very inviting. So that was nice. That's important because WireGuard goes through the networking subsystem tree, which is run by Dave Miller. So finding out that they were inviting was really a kind of a great way to get that in. The difficult part was the crypto subsystem. So Linux has a museum of ciphers inside the kernel. They've just added kind of everything over the years in really bad implementations that have not been reviewed very much. And the way they're glued together is this super crazy complex system that was originally made for IPsec, where you have to allocate memory to encrypt things and go through all this really gross kind of Windows-style APIs to access it. And when I was writing WireGuard, I had initially tried to use this and concluded that there's really no way I can write secure code and use this API at the same time. It's just not going to work. It does not lend itself to good, secure coding patterns. So I made a new API called Zinc, which is really basic. You have functions that take bytes, and the functions manipulate those bytes and return them to you. Because that's usually what crypto functions do. If you're encrypting something, you just pass it some bytes, and you get back some encrypted bytes. Or if you're hashing something, you pass it some bytes, and you get back a shorter amount of bytes that represent the hash. Cryptography functions generally tend to be fun, kind of pure functions that don't actually need crazy API integration or crazy system APIs to use them or to implement them. They're usually just kind of pure functions. There are a couple exceptions, but very, very few. So the Zinc interface just gives you functions that take bytes and do things and give you other bytes, and that's it. There's also the issue of the implementations themselves of these primitives, where a lot of the primitives in the kernel had not been very well vetted or did not have great performance. So with Zinc and the cryptography layer, I've tried to have a combination of best-in-class performance and then implementations that either are extremely widespread and have many eyeballs on them, or have been formally verified, meaning that a computer has generated them or checked them to ensure that there are no implementation bugs. And this sort of thing is important because there are a lot of primitives, for example, Poly1305 or Curve25519, that use large integers to do their calculations, integers that don't fit natively into a register on a machine, which means you have to split the integer into multiple different limbs, they're called, that then use many variables to represent one integer. It's similar to how when we do arithmetic by hand, we have multiple digits to represent one number. And with a lot of these primitives that require multiple limbs to implement, there are very subtle carry bugs, where if you forget to carry something in a calculation from one limb over the next, in a lot of cases you just might not catch it, and your test cases will continue to run, and your fuzzers will continue to work just fine. But then there's that very, very small probability that you get something where the result will be incorrect, and that can be exploited by hackers. So it turns out that formally verifying this variety of code is super important, because it's very easy to make these mistakes that are hard to catch. So Zinc tries to have a lot of formally verified code as well. So the Linux kernel challenge in this was to get Zinc upstream to say, all right, here's a separate crypto subsystem that's not hooked into any of this old legacy garbage and terrible APIs and a bunch of bad implementation. Here's like a new, fresh thing that's small and fast, good security posture, and the general WireGuard philosophy. And the crypto maintainers upstream would not have it. It seemed like they were kind of attached to their old thing, and they didn't really want this additional scrutiny. They didn't want this additional API. It was a pretty big roadblock, and I think for not altogether good reasons. So there was kind of a lot of politicking going on behind the scenes to get it in, to make it work. And ultimately, we reached, I think, a decent compromise for kind of all parties, where now Zinc lives kind of within the same directory structure as the existing crypto API, but we still have our raw basic functions. We still have the implementations and formally verified code that we wanted. And so it works and looks mostly the same as we originally intended. And now, in kind of an evolutionary way, we're morphing it toward what we originally intended. And I think we're getting there, and I think the end result's going to be fine.
Now that this is part of the kernel, Jason, how does that work as far as maintaining it? Is it just you release a build and then one of the kernel devs pull it down when they feel like it? Or is it on you to continue to update what is being pushed to the kernel?
So I'm now a maintainer at Wireguard Subsystem, and a couple other random things in the kernel. If you look in the maintainers file, you can kind of see who is responsible for what piece of code, which winds up being rather nice because that file is machine parsable. So when people want to send a patch to the kernel, they run a little script that tells them who to send the patch to. So when Wireguard changes, I make those changes, or people send the changes to me, and then I commit it to my tree. And then every once in a while, I send those changes up to the net or the net next subsystem tree, which is run by Dave Miller. And then Dave Miller takes a look and pulls it in. And then Dave Miller, when he's ready, takes all the patches that he collects and sends them off to Linus. And then Linus releases the kernel. So Wireguard is part of the NetDev family, which is under Dave. And then, networking in general, of course, is just under the kernel, which is Linus's.
How is the Wireguard experience on mobile? Is it the kind of thing that you would use to log into your company VPN and then pull some files or access some network resources and then disconnect? Or is it the kind of thing that I can fire it up and leave it running in the background?
Either way, you can turn it on and off really quickly because there's no visible connection phase that the user sees. So when you turn it on, it just kind of seems instant. Up, run, you turn it off, and you're off. But you could also leave it on all day. It's very light on battery because Wireguard was originally designed as a stealth VPN. I wanted to be able to insert this into networks and not be detected. So it doesn't send any traffic when there's no traffic to be sent. And it turns out that this stealth property winds up being really good for mobile phones because it doesn't turn on your mobile radio unnecessarily. So it doesn't use much battery when it's not in use. So you can just turn it on and leave it on all day and not really think about it.
Is Wireguard designed, or can it be run from inside of a container?
Absolutely. There's extensive support for network namespaces. So you can do all sorts of interesting things where you have the socket that Wireguard uses to send the encrypted packets in one namespace and the tunnel interface in another namespace. So, for example, you could give a Wireguard interface to a container as its exclusive ability to access the internet, so that all that container's traffic must go through Wireguard if it wants to get to the internet, and it doesn't see any other network interface. Or you could reverse things. Maybe you want your normal desktop environment to only see a Wireguard interface, and then you want to put your Wi-Fi card, your Ethernet card inside of a container. And so then you can have one place where you have things just for Wi-Fi directly, and one things where you only are using Wireguard. So you can definitely separate things out into containers and any way you like there.
How about having more than one instance of Wireguard running on a single machine? Maybe you have a terminal services-like infrastructure in which more than one user is using one machine. Maybe you have a VPN at the office, a VPN at home, a cloud VPN, and you want to be able to be simultaneously connected to those networks. Could you have more than one instance of Wireguard running?
Yeah, that works too. You can either have one instance with multiple peers. So a server would have that, for example, where it has one interface, but lots of different people talk to the server. Or you could have multiple interfaces, each with one peer, or each with a couple peers, or whatever you want. The The general structure of that is no different from anything else in the Linux networking stack, where you can add and remove virtual interfaces with the IP command. And yeah, it just kind of works as a normal Linux networking component there. You can scale it any which way you want.
Jason, talk to me a little bit about the structure of Wireguard. Obviously, with Cisco AnyConnect, and every manufacturer, every company has their own implementation of a VPN. What company or what commercial interest are you working towards?
So Wireguard is an open source project. It's free. It's not corporate backed. And the fact that we're in the Linux kernel with a networking protocol like this is really remarkable. It's hard to think of other examples where just kind of a grassroots, single author, open source, non-corporate project has really made it to a prime time Linux protocol. But Wireguard has indeed done that. And part of that is because I've not been doing the usual security consulting stuff in the last year. I've made Wireguard into my full-time job. And this has been possible thanks to lots of different donations from individuals and from companies. If you go to wireguard.com/donations, you can donate. You can also see companies that have been sponsoring us. And really, this is what's made the project be able to live and breathe and made it work. And it's again, it's really kind of a unique thing in the networking sphere to have something like this where it's not from some massive corporation like Cisco. It's really a ground up open source project where we're really not pursuing commercial things. We're just trying to get a really solid tool out there to be used with free clients and everything open source. And yeah, I've just tried to kind of put my full-time attention into that thanks to these donations.
What I like about that is it makes you beholden to the people that are actually using this project. It doesn't matter what any particular corporate interest is. The fact that you are being directly funded by the people that are actually using this means that you're just a community member, and these are just community members that are taking advantage of your project. Jason Donenfeld, he is the lead developer for Wireguard, a modern, fast VPN. You can learn more at wireguard.com. Jason, thanks so much for taking the time to come on the show. Man, did I learn a lot in this episode. We'll get you back on the program real soon.
Thanks a lot.
Now, if you want people like Jason on your end, working on your end-to-end open source VPN, then I encourage you to vote with your wallet. You heard him say it, right? This is what allowed the project to live, breathe, and work, is the donations that he was receiving over at wireguard.com/donation. And, the other thing I'll point out too, if you work in a business where you're sitting inside of meetings, and you may not be the guy that controls the coin purse, but I implore you to have that conversation. I implore you in the strongest possible way to have the conversation with the guy who does write the checks and help him to understand the value in funding the software that you're using. Because if you want these people that are passionate and want to do a good job and provide the best possible product in an open source way, then we need to fund them, lest it becomes like OpenSSL and everybody uses it, but nobody wants to fund it. I can't encourage you enough. So I've made a donation to Wireguard as a thank you for the project and for all of Jason's hard work, and I would encourage you to do the same. We'll have a link in the show notes at podcast.asknoahshow.com, or you can go directly at wireguard.com/donations. I also invite you to check out our Wireguard tutorial. Over 40,000 views on this video, and that tells me that this is a popular thing that people are trying to set up, and it tells me, and it leads me to understand that there are all sorts of different use cases, and people want something easy to spin up. And so if you want to find out how to set up Wireguard, I said I was going to do it in less than 10 minutes, and then the video ended up being like 6 minutes because it really is that easy. So we'll invite you to check that out. That's on our Minddrip Media YouTube channel, as well as we'll have it linked again in the show notes. Open phones this hour, 855-450-NOAH. It's 855-450-6624. The email, live@asknoahshow.com. Jeremy calls from South Carolina. Thanks for hanging in there, Jeremy. Welcome in.
Hey, Noah. Thanks for taking my call. I am trying to figure out how to get a Raspberry Pi 4 to connect to my Dyn.com for one of my remote sites. Easiest possible way. I'm currently going about it with Open Media Vault and Portainer to do it.
What are you trying? I'm sorry. Sorry. Back up for a second. What are you trying to connect this Raspberry Pi to?
Well, I'm trying to get it to connect to Dyn.com to forward an email or forward a domain to that site. It's for cameras, surveillance cameras.
Okay.
And the surveillance camera box is a Honeywell, and it should have capabilities to do this, which most of them work perfectly fine. But this one, for some reason, is not working, so I'm trying to just put a Band-Aid on it and get it fixed.
Well, okay, so I'd be remiss if I didn't start with the obvious, okay? So let me start with the obvious, and then we'll work backwards, all right? The obvious is having just gotten done speaking with 30 Minutes from Jason Donenfeld, what I would tell you is you should highly consider setting up Wireguard, because you won't have to worry about opening ports in your firewall and forwarding and all this other nonsense. You can simply use Wireguard either from your mobile device or from your laptop, VPN back into your actual network, and then access it over the LAN. So that's obviously one way to do it, and it's what I would encourage you to do. Aside from that, I'm not understanding the tie with Dyn.com. I'm familiar with Honeywell, and I'm familiar with their IP camera systems, but I mean usually it's just a matter of opening a port on the firewall and then using the Honeywell app to connect into the NVR.
Well, the Honeywell app we're not connected through the Honeywell. We're using Dyn.com to connect the.
Oh, I see. It's like a brokering service that brokers the connection in, so you don't have to mess with your firewall.
Yeah.
Okay. Yeah. All right, I'm with you. So what does this have to?
Yeah.
So you want that
for whatever reason the.
Explain this to me. Where does the Raspberry Pi come in? Is that what you're using to view the remote Honeywell NVR system?
No, this is just when I'm trying to get the internet. Apparently the ISP updates their IP address more.
Oh, okay. All right. I see. Okay. Yep. So we're talking about, actually, it's funny because Linux Ninja in the chat room points out what you're dealing with is a dynamic DNS issue. And so here's how you would go about solving that. There's a couple ways to do that. The easiest solution is to use something like NoIP. You can go to NoIP and sign up for a free account.
This is the corporate version of NoIP.
Oh, okay.
They give us 35 addresses per month or per year or whatever.
Okay. So what is not working? That when you go to one of the IP addresses that it's giving you, it's not forwarding it correctly?
Right. Yeah, I'm not able to, I type in the name, the real name, and it's not getting there.
I doubt that has anything to do with your Pi, my friend. I strongly suspect that there.
I don't have a Pi yet.
Okay, well, here's what I would suggest you do. I think we're kind of going in circles here, but here's what I would suggest that you do. I would suggest that you work with whatever company that you're using to deal with the dynamic IP and have them sort through the issues of the IP address not forwarding to your, or updating your new dynamic IP. So that's the first thing I would do. If for any reason you can't make any headway on that, then the second thing I would do is I'd go ahead and look at a different dynamic IP provider, because there are tons of them out there. And the reason I recommend NoIP is because you don't have to pay anything, and you can simply use a script every, I think it's 30 days. You just have to renew your account, and they will allow you to do that. So I would encourage you to do that. And then as a last resort, if that doesn't work, then I would start looking at things like Namecheap and so on and so forth, where you can purchase a domain, and they actually have their own client that can run on your router, on a VPS or something like that, and update the IP from inside your network and then publish it to your domain. So I've used NoIP, so I know that system works. I would suggest you to give that a shot and go from there. 1-855-450-NOAH. It's 855-450-6624. The email, live@asknoahshow.com. I wanted to get to a piece of feedback here. Steve wrote in a few weeks ago, and he was asking about syncing SSH configs. And I gave him the best answer I could, off the top of my cuff. But later, in our interactive Telegram group, we got into a discussion about Remina. Now, Remina is an open source desktop control software. It's primarily used, or at least I primarily use it, for RDP connections when I'm working with Windows clients. But it actually has the ability to authenticate into SSH, and it provides a very nice graphical interface and the ability for you to save the username and passwords of all of these different SSH servers. And so if you're looking for a graphical way to manage SSH connections, Remina sure isn't a bad way to go. And then, of course, you can sync that around with other machines, which is what Steve was asking to do. So, again, I'd be remiss if I did not bring that up and give credit to our interactive Telegram group who came up with that answer at telegram.asknoahshow.com. I will point out that I wasn't able to get PKCS11 working with it. That's not to say that Remina doesn't support PKCS11. It just means I'm not smart enough to figure it out in the 5 minutes I was playing with it. And so because of that, I wasn't able to use it with my YubiKey. Therefore, it kind of stamps it out for daily use for me, but certainly something that you should be aware of and check it out. Our next email comes from James. James writes in and says, "Hello, Noah. Hope you're doing well. Regarding the circumstances we currently live in, I was really happy that you mentioned the OSI model as a tool for troubleshooting. It helped me better understand the session and presentation protocol with your statement. I used to work as a waiter, and that's quite a change. I'm really glad that I've made the move, but it's been tough, and I absolutely had no knowledge 6 years ago. I kept the hard work, and it paid off. I feel privileged to do something I really like, day in and day out. Moreover, it's really great. It's a really great job with tons of things to learn. I wanted to thank you for hosting the show. I started listening to you a while back, and I was thinking I could listen to a podcast because I'm so often on the road. And so I thought I would listen to a podcast about Linux. That's when I discovered your show. It's really great, and it allows me to learn something valuable. For example, I learned about Wireguard on the first show I listened to, and I was like, what is this? I think you're a great listener to your audience and always tries to help them. I really like Linux and its culture. I think it's more appropriate of my way of thinking. And by that, I mean collaborating and helping others. I hope you understand what I'm saying. I would really love to work in the future as a Linux tech or for a Linux project. I still have a long way to go, but I know that's what I'm aiming for. I'd ideally like to manage my own mail server. I've tried Plex, Nextcloud, and I found those pretty easy to install. Next, I'm going to try WireGuard, and I'll have to look at your YouTube videos. Is there any installation or tips recommendation that you could recommend for deeper learning into Linux? Once again, I want to thank you for hosting the show, and I hope to listen for a long time. Well, first of all, thanks for writing in, James, and the kind words. What I would tell you, if you want to dig into Linux and you really want to start to understand what you're doing, I suggest looking at distros like Arch and Manjaro and Gentoo. Any Linux distro that allows you to explore the underpinnings of Linux is going to give you a greater understanding of how those systems work. Anything that doesn't come pre-bundled or pre-installed and forces you to have to apply those individual applications or individual things, that's something that is going to create a learning opportunity for yourself to better understand the system. A couple of administrative stuff I want to get to, too. Southeast Linux Fest is officially canceled for in-person, but as in past years, we have done the remote attendee option. You might remember that yours truly hosted the remote attendee option live from Southeast Linux Fest. Well, guess what? I sat down and had a conversation with Jeremy Sands and said, hey, just because we can't all meet in person doesn't mean we can't Linux. I mean, we're tech guys. We can do this. And Jeremy said, yeah, I would love you to do that. Let's go ahead and do a remote attendee option. So self in person will not be there, but the remote attendee option will be available in 2020. It will happen on the exact same weekend as Southeast Linux Fest, and we are going to approach the speakers that we're going to present at Southeast Linux Fest, or at least the ones that we think would be a good fit for our remote presentation of self. And we are going to have an interactive chat room and an interactive video chat that you're going to be able to ask the presenter and hear the presenter and see those presentations just as if you were at self. Now, nothing will be able to replace the in-person experience itself, and I wouldn't claim otherwise. I highly encourage you to attend Southeast Linux Fest if you ever have the inclination to do so. But this is going to give people an opportunity who wouldn't ordinarily be able to attend. And it's also going to bring some normalcy to COVID-19 and the havoc that it has wreaked on our Linux community, because this is the only time we get to meet with friends. So we're going to have in between presenters how-to tips, how-to segments, short segments, things that will inspire you and help you learn things as we go along. And of course, you'll have the presenters that are willing to present remotely. Hey, make sure to check out the podcast dashboard by going to podcast.asknoahshow.com. You'll find all of the articles and references I used to make the show. We'll be back next Tuesday at asknoahshow.com. Have a great week.